Hi guys, so today we're going to start talking about the kinds of air pollution in our atmosphere. This is a pretty serious conversation because even though in the United States the quality of our air has been very slowly improving, we still have some profound health effects that occur from the amount of air pollution in the air. It's estimated that 2 million premature deaths occurred worldwide every year because of the quality of our air or lack of quality in some places. So what are the sources for air pollution? There are natural sources for air pollution like dust. And dust can be a tricky one because sometimes if you go back enough, it's actually man-made and other times it isn't. If you look at the picture down below, that's from the Great Dust Bowl that occurred in the 1930s, right around Depression time, and actually lended a hand in the Depression. There was a bunch of droughts that year, and farmers didn't take proper precautions for that, either because they did not know or they just did not do it. And so a big windstorm came up and picked all the dust, and when the dust came down, it covered any surviving crops, homes, people suffocated. It was really terrible. And so it led to a shortage of food. Other things that can affect that are volcanic eruptions or wildfires even. Now, with the dust, I did a symposium on dust, African dust in particular, through NASA. And because of the process of land turning into deserts, because of cutting down too many trees in Africa, the wind is picking up the soil, because it's also, they have drought seasons, and carrying it over into the ocean. And this is causing red tide in the ocean, because that's all the nutrients that should not be there are now in that water from all this dust due to drought, which is associated with deforestation and climate change, which are all sourced in human activities. So our activities can affect these large effects. They can affect them. So directly or indirectly from the burning of fossil fuels. So directly is the fossil fuels themselves produce pollutions in the air, as we will see, but also indirectly with global warming. So here you can see the African dust that I was referring to coming off the continent of Africa, and they can see this from outer space, and NASA takes these photographs. The lines obviously are not there. The lines were put on there afterwards digitally so that they could see where the different countries were to determine the origin of this dust to see if we could mitigate this a little bit. And so this African dust is flying over into the ocean and putting those nutrients in. So here is industries pumping pollution directly in there. Now the clouds that you see coming out of the smokestacks are actually mostly water vapor. But within that are things like nitrous oxides, volatile organic compounds, sulfur compounds that all lead to health issues associated with air pollution. So primary air pollutants are things put directly in the atmosphere. So this is the pollution that comes out of our vehicles when we drive them and the pollution that we see directly coming out of the smokestacks of industry. So soot is a great example of that, whether from industry or from wildfires even. Secondary air pollutants is when all these pollutants go up into the atmosphere, they interact with each other. And when they chemically react up in the atmosphere, because remember there's moisture in there, there's water vapor, and most chemical reactions are occurring in water. Water is the universal solvent. So when these molecules are interacting up in the atmosphere, they combine and they usually land up making worse things. So the secondary air pollutants, as we'll see, can contain things that are acid. So acid up in the atmosphere, no bueno, right? So we're going to talk about what that does. So here's some more smokestacks. You can see the soot. And we do have ways to mitigate this. It's just whether we hold these industries accountable or not, which is a tricky thing because on one hand they employ people and we want to keep those jobs there, but on the other hand we need to maintain the quality of our air and water so that people can live healthy lives. So here's a diagram kind of showing how these secondary air pollutants are made. So industries give off sulfur dioxides and nitrogen oxides. The X is there because it could be a variety of things like 2 or 3. And when they combine in the atmosphere with other oxidants and water vapor, they create acids. So you got sulfuric acid and nitric acid. And what these acids do is they condense in the clouds and they fall as acid rain. So here's a diagram showing which countries are producing the sulfur dioxides. And so you can see it's not just us, and actually compared to Asia, we're not too bad. But we definitely create quite a bit on the eastern side of the United States. And the hard part is, even though it's produced here, that's not necessarily where it stays, because we are one world, okay? And weather and wind currents do not abide by the borders that men have decided on. So the pollution that is created in one place does not necessarily stay in that place, so it can affect you in other places that you live. So how do they affect us exactly? Well, they cause lung irritation and respiratory illnesses, things like bronchitis and pneumonia. And then we've seen huge increases in cases of asthma, and it fouls where the air pollution is occurring. So in areas where the air has more particulates in it due to pollution, we see higher rates of asthma. They're very tightly correlated. We also have different kinds of air pollution like carbon monoxide, which you may have heard about in the news recently because a family was affected by it. That's not the same as carbon dioxide. That's what you breathe out. Carbon monoxide is just CO, and that is produced like from some vehicles, and it interferes with your ability to take up oxygen. So you actually land up suffocating and you feel like you're breathing because you're physically breathing, but because you're breathing a different gas and that gas still attaches to your hemoglobin, you don't actually pick up any oxygen, so your cells are suffocating. And so if you have carbon monoxide poisoning, you will land up kind of getting kind of sleepy and disorientated, and then you will pass out, and then you will die. So other kinds of pollutants we see is benzene. We talked about benzene in our TAPT video. That's produced a lot in the plastic industry, and it causes cancer and adverse reproductive outcomes. Soot, of course, you don't want to be breathing that stuff in, and those have been directly related to cancer. So signs of carbon monoxide poisoning, just to keep you guys safe: if you walk into a garage or a building and you get a headache and then you get nauseous and you get dizzy and then you're having a hard time breathing, you need to get out of the building, all right? At a minimum, open some windows. And then you need to call your first responders to come check if there's something going on, some kind of leak, especially if you have a house where your garage is underneath your house. Because if you leave your vehicles running and they do produce carbon monoxide, and it's an airtight situation, that can leak up into your house and cause issues. Now, newer cars make very little carbon monoxide, but an older car from years ago, they make quite a bit. So part of it depends on the kind of car you have and the type of house you have. But especially if you're like a mechanic or something, that's something you do need to be aware of. So here's just some data showing the link between traffic fumes and childhood asthma. And so the incidence and the rate of asthma due to traffic pollution by country. And so if you look at the countries that are up here at the top, Kuwait and the United Arab Emirates, these countries are rich because of oil. And so they're burning a lot of oil. Canada has to do with their cities. Their cities are very tightly packed, like New York City, so think like Toronto. And so because of that, they get a lot of condensed pollution, not over the whole country, just in these particular places. All right, and here we are in the United States. So we're not at the top of the pack, but we're not too far off. So these are just things to be aware of, that it is directly linked to this through many, many studies. Just to give you some ideas about sources of carbon monoxide besides your vehicle, which we talked about, your dryers can be a source of carbon monoxide. That's why they need to be vented to the outside. You should have a hose, and you need to clean your hose periodically of dryer lint so that A, it doesn't catch on fire, and it doesn't block the carbon monoxide from leaving your home. So if your parents are not aware of that, that's something you should let them know about. Your water heater and your furnace could produce carbon monoxide. That's why you need to keep those in good working order. If you have like a propane fireplace, you shouldn't have leaks. If you smell gas when the fire is burning, that's a problem. If your fireplace is in bad repair, this again will also cause fires, so it's definitely something you need to take care of. If you have a stove that's a gas stove, an electric stove is not going to do this. If you have a gas stove, you need to make sure that everything's working properly there. You should not smell gas. And then outside, the generators, this is a big deal too, because some people misguidingly put their generators inside homes or inside the garage. Generators, the gas they give off is very dangerous. It needs to be outside or in a well-ventilated area. So if you're closed up in your garage with that running, you're breathing in gases that you should not be breathing in. All right, same with your barbecues. If you're barbecuing in the rain, make sure the door to the garage is at least open. So let's talk about smog. Smog is one of the air pollutions that's been very linked to upper respiratory disorders. And its name is kind of a mixture of what it is. It's smoke and fog that combine, all right? So it's all these air pollutions that form over cities, all right? So it tends to condense there, especially if your city is in a valley, like ours is. Luckily, we have a smaller city, so we don't experience things like this. But a lot of big cities like LA, they experience a lot of smog, all right? So industrial smog is soot and sulfur and water vapor comes when you have a lot of industry in that area and it's pumping that stuff into the atmosphere, especially if it's not regulated. Photochemical smog is mostly up in the troposphere area, and which is where we are, and it's created when these primary pollutants from vehicle exhaust react, and that's why we see them in places like LA. China has a real big problem with photochemical smog too, because their population is so dense. So there are weather conditions that can make the smog bad, and so you have smog days and non-smog days, and they will actually have, in places that experience this extreme smog, they will have warning days that say stay inside because the smog is bad today. And so it has to do with these things called temperature inversion. So normally air near the Earth's surface is warm. And so when it's warm, warmer air rises. So the warm air will rise up into the cooler air in the atmosphere, and this will dissipate some of that pollution up into higher levels of the atmosphere. And this is the normal thing that occurs. But every now and then we have a temperature inversion. And what happens is the air down here is cooler and the air in the atmosphere is actually warmer. And when this happens, warm air rises, but the cold air sinks. And so by doing this, it kind of traps all this smog down by your city, and that's when you have smog days. The other thing we need to be aware of is that acid rain or acid deposition. That's when our primary pollutants react in the atmosphere, creating secondary pollutants when they react with water and oxygen and ozone and form acids. And then that acid, like I said previously, lands up in the clouds and falls as acid rain. So what's the problem with this? It's not like acid rain doesn't fall on you and melt you. It's not acidic enough to do that. But as it accumulates on the land and in the water, it can harm our ecosystems and even our structures. So we have a lower pH of rain and snow, and lower pHs are acids, and it's going to harm our forests, lakes, and damage human structures. And like I said previously, the pollution can be made in one place, and the weather moves it, and it can fall in a totally different place that's not producing the pollution. As a matter of fact, a lot of our pollution lands up affecting cities in Canada, which they're not too happy with. So this is what a forest that is experiencing acid rain might look like. When it falls on the plants, obviously acid, not good for plants. The plants land up dying, and you could decimate an entire ecosystem. All right, here's another forest that is experiencing acid rain. And then sometimes on the news, they talk about these large fish die-offs, and sometimes that's due to eutrophication, when you have too much nutrients in the water and it makes algae grow, and then when the algae dies, it sucks up all the oxygen. But the other thing that can happen is you can alter the pH of the water. Water should be around neutral, which is 7. And if you make it acidic, fish life, they can't survive in that. And so you have these huge fish die-offs, which is a food source for us. We also see evidence of acid rain in our monuments. So this is a monument, I think it's in Toronto, Canada, I can't remember for sure. And these pictures were taken 10 years apart. Okay, now this was made out of something called limestone, which is very common in our area. And limestone is especially sensitive to acidity. And so it literally melts the rock. And that's what you see happening there. The good news is, at least in the United States, we have taken some measures to make this a little bit better. We have started holding industries accountable, and when we do that, it improves things environmentally. The problem is it's very fickle, and it depends on politics. But in 1994, which for you guys was a very long time ago, this is a map of the pH of the rain that was falling in the United States, and the Northeast had a lot of acid rain that was occurring, and that makes sense because there's some very large cities here, and remember also that it moves around. Well, in 2008, a couple years later, you can see the improvements that we've had. And I couldn't find a good, more recent graph, but I found one with a different scale that showed that things are getting better as long as we keep those regulations in place. When we start removing regulations on industries, they don't want to spend the money on things that are going to clean the air if they don't have to. And so then we can land up back in this spot.